Okay, so we're trying to check 5, which is theory. And this is homework from the first section, which is talking about prime composite numbers. So prime numbers are numbers that you can only divide by 1 or itself, but you can't divide by any other number. And composite numbers are numbers that you can divide by prime numbers. So we're actually going to do problems 1 through 8 first. These are true-false questions. Decide whether each statement is true or false. So number 1, every natural number is divisible by 1. Well, natural numbers are counting numbers. 1, 2, 3, 4. Any number is divisible by 1, so that is true. There are no even prime numbers. Well, there's only one even prime number, and the even prime number is 2, so that is false. It's not very false because every other even number is divisible by 2, but 2 is a prime number, so that's false. If n is a natural number and 9 is, well, that's this terminology that uses a little vertical line, which I never remember anything about. So what the heck does that mean? Well, a vertical line means that 9 divides 45. So what it's saying is there's some number that divides by 9. Does 3 divide that number as well? Well, yes, because 3 divides 9. So that has to be true. Number 4, if a natural number, n is a natural number, then 5 is a divisor of n and 10. Well, that's the other way around. So an example would be, 35. If we had 35 or 5/35, that says that 5 is a divisor of 35. You get a whole number, so 35 divided by 5 is 7. But if you said 10, is that true? Well, that's not true because you cannot divide 35 by 10 and get a result, a nice whole number result. So it's not a divisor, so that's false. Whereas over here, let's just use an example. Let's say 9 divides 81. Does 3 also divide 81? Well, yes, because 3 divides 9. So in this case, the answer would be 9. In this case, it would be 27. So you do get it. So that's, sometimes you can just use things to contradict it, and then you can use that contradiction to show that it's false. Number 5, 1 is the least prime number. Well, actually, 1 is not a prime number, so it's not the least prime number. The least prime number is 2. So 1 is not a prime number, and that's why it's not the least. 2 is the least prime number. 6, every natural number is both a factor and a multiple of itself. So the answer is true. Why is that the case? Well, what is a factor? Let's see if we have a definition for a factor. If a natural number A is divisible by a natural number B, then B is a factor. So a number is always a factor of itself. So if you were saying, here's the number 12, what are the factors of 12? The factors would be 1, 2, 3, 4, 6, and 12. Why is it so? Because 12 divided by 1 is 12, 12 divided by 2 is 6, 12 divided by 3 is 4, 12 by 4 is 3, 12 by 6 is 2, 12 divided by 12 is 1. So these are the factors, and so you can see that the number is a factor. Now the second thing is a multiple. So what is a multiple? Well, let's find a definition for a multiple. Okay. It says if If a natural number A is divisible by a natural number B, then B is a factor of A, and A is a multiple of B. Well, it's the same way. So this is a multiple of that. This is a multiple of that. This is a multiple of that. So it works both ways. Okay, number 7. If 16 divides a natural number, then 2, 4, 8 must also divide the natural number. So let's use an example. Let's say 64 divided by 16. So this 16 does divide 64 because you get 4. You get a whole number. So the question is, does 2, 4, and 8? Well, 2, 4, and 8 are factors of 16, and so therefore they are also. So if you, for example, did 64 divided by 2, you get 32. If you did 64 divided by 4, you get 16. If you did 64 divided by 8, you get 8. And so because these are factors of that, it does divide. So the answer is true. And 8 says, the prime number 53 has exactly 2 natural number factors. What are they? They're 1 and 53. So every prime number has 2 factors, 1 and the number itself. So this doesn't just apply to 53, it applies to every prime number. It has exactly 2 natural number factors. Okay, let's do number 9. Find all natural number factors of each number. So here's 12. The question is what numbers multiplied together give 12. So we know 1 and 12 do it. If you divide by 2, you're going to know 2 is a factor. So you get 12 divided by 2 is 6. You have 12 divided by 3. 12 by 3 is 4. And then you get to that point, and there's really nothing else in there. So these are the factors. 1, 2, 3, 4, 6, and 12. Let's do number 12. What are the factors of 172? Well, you'd write 1 and 172. So those are 2 factors, just the number in itself. So if there were no other factors, that would be your prime number. So if you divide by 2, you're going to get half of 172. So let me use my calculator so I don't make mistakes. Divided by 2 is 86. And so since 86 can be divisible by 2, then we know that 4 would be another factor. So we take 172 divided by 4, we get 43. Now, the possibility also would be 3, so let's try 172 divided by 3. We get 57.33, so 3 is not going to work. We're not going to be able to divide by 5 because it doesn't end with a 0 or a 5. 6, well, it didn't get divisible by 3, so it's not going to be 6. 7, possibly, let's try 7. 172 divided by 7. 24.6. 7's not working. 8 might work because, well, 8 will work because we have 2 and 4, I think. So let's try 172 divided by 8. 21.5. So it's not necessarily the case. So that doesn't work. Because it wasn't divisible by 3, it's not going to be divisible by 9. You get to 10, that's not going to work. 11, well, you take the square root. I think if you take the square root of 172, we get 13. So we only really have to go up to 13. So 11, 172 divided by 11 is 15.6. That doesn't work. 12's not going to work because that has 3 in it. And we have 13, which isn't going to work. So we can kind of, now we can put them all together. 1, 2, 4, 43, 86, 172. let's look at 16. Use divisibility test to decide whether the given number is divisible by each number. So the numbers we have are, well, let me write the number up here first. So the number is, actually, we'll do 14, not 16. So our number 14 is 540. So we have 2, 3, 4, 5, 6, 8, 9, 10, 12. And all we need to do is we need to go to the list to look at the rules, because I can't memorize them. So any even number is going to be divisible by 2. So that is true. Let's see if they just want to know whether it is or not. Decide whether the number is divisible by each number. Okay, so we say yes, it is, because it's an even number. What is it? 540 divided by 2 is 270, so that's the result. 3 says the sum of the digits is divisible by 3. So if we take 5 plus 4 plus 0, we get 9, which is divisible by 3. So the answer is yes. So if we take 540 divided by 3, we get 180. Divisible by 4, it says last 2 digits form a number divisible by 4. Is 40. Can you divide 40 by 4? Yes, you get 10. So the answer is yes. So 540 divided by 4 is 135. 5. Well, if the last number is either 0 or 5, then it is. So yes, that's true. So take 540 divided by 5. We get 108. 6 says numbers divisible by both 2 and 3. Well, yes, it was both divisible by 2 and 3. So yes, it is. Take 540 divided by 6, we get 90. 8. Last 3 digits form a number divisible by 8. Last 3 digits form a number divisible by 8. Well, we only have 3 digits, so we just take 540 divided by 8. Basically, I have to do the calculation, and you get 67.5, which is not. So if we take 540 divided by 8, it's not a whole number, so no. And if you divide it out, you get 67.5. 9. The sum of the digits is divisible by 9. So we take 5 plus 4 plus 0, which is 9, which is divisible by 9. So yes, it is divisible by 9. So 540 divided by 9 is 60. Divisible by 10 has to be a 0 in the last. So yes, it is. And that's 54, of course. And 12 has to be a number divisible by both 3 and 4. So that's true. So it's yes. And so if we take 540 divided by 12, we get 45. So the only number it's not divisible by is 8. I'm just checking to make sure I did everything right there. Actually, I don't show the answer, but I'm pretty sure that's right. Well, let me just stop it. I'll check the answer book. Okay, so we're correct, which I would have been surprised if I wasn't. It's pretty straightforward. Now we have 123,456,789. So we go through the same set of numbers as we did before. Now, since it's odd, we pretty much know it's not going to be any of these even numbers. So we're going to say no, 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 and no. Okay, so all we have left, and also we know, let's see. Okay, so 5, well, there's no 0 at the end, so it's no. It's not. So the only one was we have is 3 and 9. So we have to add the numbers together. So 9 plus 8 is 17, plus 7 is 24, plus 6 is 30, 39, 42, 44, 45. So if we add all those numbers, we get 45. Is 45 divisible by 3? Yes. And so if it is, then if the sum of the numbers is divisible by 3, 45 divided by 3 is 15, then that's true. And 9, well, 9, yes, 45 is 9 divided by 9 is 5, so both 3 and 9 are you can divide that into it. But all the other ones is because they are even numbers, so you don't have to worry about it. You could go through more of these more complicated things, but the reality is that if it's not an even number, you can't divide an even number, a non-even number by an even number. It's not going to work. Okay, let's stop there and we'll do another section.